everyone, welcome back to this channel. In today's video we are going to start with a very important method called method of undetermined coefficients. We saw in the last video that for a non-homogeneous differential equation which is linear and having constant coefficients, non-homogeneous means where you have right hand side as non-zero, the solution, the general solution comprises of two parts, yc and yp. Yc is called the complementary function, which is obtained after finding the initial equation or what we call as characteristic equation, and after solving for the roots of the characteristic equation. Depending on the nature of roots, we write our yc. So yc is just the solution of the associated homogeneous differential equation, and yp is one particular solution of the given differential equation. In the previous video we saw we discussed an example where we could find out yp just looking at the equation. We could guess what one of the particular solutions can be, but every time the given equation may not possess a very simple observation oriented yp. So for that yp you have two methods for finding yp. These are two systematic methods that help you to find the particular integral. One is called method of undetermined coefficients and the second one is called method of variation of parameters. Now method of undetermined coefficients is what we are going to discuss in today's video. Now as the name suggests, for finding yp through this method we are going to set up a trial yp. We are going to guess some yp that this may work, and that guess will involve certain undetermined coefficients which we are going to obtain looking at the equation. According to the given equation we are going to obtain those undetermined coefficients, and that's the reason it's called method of undetermined coefficients. Now how do we set up trial yp looking at the equation is what we are going to learn in today's video. And of course the solution in the end will be given by yc, the complementary function, plus the particular integral. So the whole idea of this video is to find out yp component of a non-homogeneous differential equation's general solution through method of undetermined coefficients. So how do we set up a trial yp? We are going to guess a function which can possibly work as one of the particular integrals, and then we are going to impose the equation on that trial yp to obtain the undetermined coefficients which we are going to involve in our guess. So let's just look at the simple situations in this video. We are going to do this method in two three parts, two three videos. It's a long process, and in today's video we are just going to focus on this simple case. Now what do we mean by simple case would be clear once we discuss non-simple cases in the next video, but for now you can just look at this table which has been set up as trial yp. And how do we set up trial yp, I'm going to explain in a little while as this video progresses. Now for a term on the right hand side that does not correspond to a root of the initial equation, the following table can be used. So this meaning of this will be clear to you once I discuss non-simple cases in the next video. So for now you can just look at this table. Suppose there is a right hand side involved in the given differential equation, the fx component. The right hand side of the differential equation given to you is an exponential function. Now that means we have to think of one particular solution such that the linear combination of its derivatives lands into exponential. So obviously an exponential can be obtained through linear combination of something if it is itself an exponential function, because the derivative of exponential function is the exponential function itself with at the most a constant attached to it. So whenever the right hand side is e to power kx, you can try the guess yp, your trial yp can be a constant times e to power kx. Now this in particular obviously covers the constants also, because if you have just a constant on the right hand side, let's say k, then you can think of k as k e to power 0x, and hence try a e to power 0x, or just simply a as your trial yp. So if the right hand side is just a constant, you can guess your trial yp to be a constant itself. So that comes as a particular case of e to power kx. So for example, suppose the question is y double dash plus y equal to e to power x. Then yc you would have obtained. What you can try is your trial yp can be a e to power x, because looking at the right hand side you can guess that such a function is going to fit into it. And then once you guess that this is trial yp, that means you are claiming, you are assuming that this function is going to work as one of the particular solutions of this differential equation. So if this is a solution, then yp should satisfy this. So what will be yp dash? It will be a e to power x only. Yp double dash will be a e to power x again. So if you substitute this in the given differential equation, what will happen? Yp double dash, that means a e to power x plus y itself, a e to power x, should be e to power x. If this trial yp, the guess function that you have guessed just now through the table, is one of the solutions of this differential equation, then it must satisfy. Now for it to satisfy, it should satisfy this differential equation. That means 2a e to power x is e to power x, and you know that two expressions are equal if the coefficients of the like terms are equal. Now here e to power x's coefficient is 2a and here e to power x's coefficient is 1. So that means that's possible only when 2a is 1 or a is half. So that means this is very much working, and it's telling you that your yp is a should be half e to power x. So you can convince yourself, you just put yp as half e to power x here in the differential equation, you'll see that it's getting satisfied, because if yp is half e to power x, then yp double dash is also half e to power x only. So it's half e to power x plus half e to power x equal to e to power x. So it's very much satisfying. So this is how you assume a guess function, and then that guess is going to involve certain undetermined coefficients, and those undetermined coefficients will be obtained after substituting your guess function in the given differential equation. If everything works well, it's a simple situation. What is simple, what is non-simple will be clear in the next video when you come across situations where such simple trial yps are not going to work. We'll have to modify them. So I'm going to teach that in the next video, but for now let's first understand how to address simple situations where, looking at the right hand side, you make a simple trial yp guess, and that trial yp guess works well with respect to calculation of the undetermined coefficients involved in the guess function. So here, when you assume that the guess function is a e to power x, looking at this table, because if it's e to power kx, we guess a e to power kx. So since it was e to power x, so we guessed a e to power x here, and it worked well with this restriction, a equal to half on the undetermined coefficient a, and hence it told you, the procedure told you, that yp equal to half e to power x is going to work in this scenario. So this is how you find out yp. So the final solution to this problem, you can see that what will be the yc component here? The yc component, r square plus 1 equal to 0. So r is plus minus iota. So for this question, the final answer will be y equal to yc will be c1 cos x plus c2 sin x. That will be your yc, because your characteristic equation will have plus minus iota as its roots, and your yp has got this form after applying the method of undetermined coefficient. So this will be the general solution of this example which we have discussed just now. So whenever it's an exponential function, you have to take, so let me erase all this example so that the table is clean for you. E to power kx, whenever there's a term on the right hand side which is an exponential, then guessing a constant times the same exponential works in most of the situations. It's not going to work in certain special cases which we'll be discussing in the next video, but for now you can assume that if it's an exponential, then exponential with a constant attached is going to work well, and if it doesn't work well, we are going to modify it later on to accommodate the change. And what is that change? We'll discuss that when we come to non-simple problems. So for now, let's stick to simple problems. If it's exponential, just guess a e to power kx. If it's just a constant, say k, then you can just guess a constant a. This can be your trial yp. Now suppose it's a power, say x square, then you will guess ax square plus bx plus c. So you will consider, because since you are taking the left hand side is a linear combination of the derivatives, and you know for the derivatives of x square it's going to be reduced powers only. So you will take x square, x, and x to power 0. So if it's x cube, you will guess ax cube plus bx square plus cx plus e. We avoid the symbol d because d is reserved notation for differential operator. So try to avoid that in the undetermined coefficients. So in general, if it's x to power m, then you can have am x to power m and all reduced powers up till the constant term. So if it's x4, you can try ax4, bx cube, cx square, ex plus f, and so on. So for all polynomials, it's going to be the polynomial having all the reduced powers also. So if it's a monomial, then you'll take the reduced powers also. So that's the guess function which works well in all the simple cases. I'm repeating, simple has got something to do with the roots of the characteristic equation. So you'll understand that better in the next video when we come to non-simple problems, and this table is not going to work there. So then you will be modifying these trial YPs, but for now we'll be sticking to problems which are simple ones, and you can straight away use this table. So for exponential, it's a constant times the exponential itself. For a constant, it's the constant. For x to power m, it's x to power m and reduced powers, the linear combination of the reduced powers also. Suppose the right hand side is now sine or cosine. So what can be your guess in this case, because left hand side is a linear combination of the derivatives. So sine's derivative can either be cos or sine depending on the order of the equation. So whether it's sine or cosine, you can take a linear combination of sine and cosine both to work as a trial YP, and your A and B will be adjusted according to the question. So let me demonstrate some of the examples. For example, the right hand side term is 3e to power x. Suppose that's this is the term 3e to power x. Sorry, it's hanging. Wait. Yeah, so suppose it's 3e to power x, your right hand side. Left hand side is some equation, y double dash plus something something equal to. Right hand side is 3e to power x. Now since it's e to power x and this constant is there, so you'll just take a e to power x as your trial YP component. If it's 4x square, it comes under the specific case of x to power m, so you'll take ax square and all the reduced powers. If it's another exponential e to power minus 3x, then you will take e to power minus 3x, but of course a constant would be attached. So this will be a specific case of point number 1. So let's move on. Look at this. Suppose it's exponential into cosine. For exponential, what do you guess? You guess a e to power minus 3x. But for cosine, looking at bullet number 3 of the table, sine or cosine, you take a linear combination of sine as well as cosine. So here it's cosine, so you'll take b cos x. So let me tell you, how do you simplify your trial YP in these situations? Wait. Yeah, so it's wait. B, it's something got selected by mistake, just wait. Yeah, B, it's again not letting me write, just pardon me. I'll have to close this, and I hope it works well. No. So yeah, coming to this, now it should not be hanging. So for e to power minus 3x, the guess will be a e to power minus 3x. And for cos x, it's b cos x plus c sin x, right? Now let's look at the type of terms that are obtained. So it's going to be a into b, a constant, let's call it as k, into a term which is a combination of the product of e to power minus 3x and cos x. Then ac, which I can call as another constant, e to power minus 3x into sin x. So ab can be given a name, let's say k or a, and AC can be given a name, let's say B or whatever you want to give. So try to write the minimum number of constants that are possible in your final trial YP component, because you have to look at the nature of terms that you get. For exponential, the guess is a e to power minus 3x, and for cos x, the guess was a linear combination of cos x and sin x. So you open the bracket and look at the kind of terms which arise out of it. So it's a constant times e to power minus 3x into cos x, and another constant times e to power minus 3x into sin x, and therefore your trial YP looks like this. Similarly, if you look at this, for the x component, if you look at it as a monomial case with x to power 1, m equal to 1, ax plus b will be your trial YP, and for the sin x part, it's going to be c sin x plus e cos x. So let's open the term ax c sin x. So it's a constant times x sin x type term, a constant times x cos x type term, then b c sin x. So there will be a constant times sin x type term and a constant times cos x type term also, c sin x plus e cos x. So this will be your final trial yp, but in most of the cases the left hand side will be having plus minus iota affected, and that's the reason it was not written here. But if it's a simple situation, you will have terms involving c sin x and e cos x also. So you should modify your trial yp as ax sin x plus bx cos x plus c sin x plus e cos x. This will be your final entire trial yp. In most of the situations we'll be writing these because these will be redundant, that I'll explain when I discuss the non-simple cases. But for now, since we are discussing only a simple situation, so you will take these 4 terms as your trial yp. Now moving on to 3x plus 4. For 3x you will write ax plus b, and for plus 4 you will write another c. So what is the type of terms? You are getting an x type term and a constant. You do not have to write b and c separately. Even if you write b and c separately, it's not going to matter in the end, but since it's unnecessary, because I told you that you have to look at the form which trial yp is attaining. The form is that it's comprising of an x term with a coefficient which I have taken, and b plus c can be clubbed together as a single constant. So it's a constant type term and a term which is power x to power 1 with a constant. So try to write the minimum number of constants. Just look at the nature of the terms and club the terms which are similar to write those coefficients as a single coefficient to avoid any complicated calculations. Now look at this one. For 3x square you would write ax square plus bx plus c, and for this constant minus 1 you would write another constant, say e. But then look at the nature of the terms. It's an x square type term, x type term, and then there's a constant type term which you can just write as plus c. You do not have to write plus c because it will be unnecessary. Even if you write plus c, it's not wrong, but it's unnecessary. Now let's look at cos hyperbolic x. We know that the definition of cos hyperbolic x is e to power x plus e to power minus x upon 2. So it's actually a linear combination of e to power x and e to power minus x. So for e to power x, it's a e to power x, and for e to power minus x, it's b e to power minus x. Even if it's sine hyperbolic x, which is e to power x minus e to power minus x upon 2, you will have the same trial yp. Now look at sine square x. Sine square x can be written as this formula, so you can write it as half plus half cos 2x. So for half you will have a constant, and for cos 2x type term you will have a linear combination of cos 2x and sin 2x coming in your trial yp. Even if you do not write it like this, you write it as sin x into sin x, and guess for sin x will be a sin x plus b cos x, and then multiplied with c sin x, e cos x, and then you club the terms together. It's going to be ac sin square x, then ae cos x sin x, then bc sin x cos x, then it's going to be be cos square x, which can be easily combined using the formula, double angle formula, to write them in this form. So you either use sin x into sin x combination, but this is a better way because you can straight away translate into cos kx format, and for cos kx the trial yp is b cos kx plus c sin kx. So k equal to 2, for k equal to 2 you can straight away use the trial yp from the table. Now let's look at x e to power x. What would you guess if the right hand side is x e to power x? For x you will do ax b plus b. For e to power x you would do c e to power x. So let's look at the nature of the terms now. A x c e to power x. So it's like a constant times x e to power x type term, and then b c e to power x, so a constant times e to power x type term. So you have to look at the type of terms that you're getting. I'm repeating. So for this it will be a constant times e to power minus 5x, and for 7 it will not be 7, it will be b. Sorry, this is a typo mistake. This is going to be undetermined coefficient b. It's not 7. For 7 you will have b as your guess on the right hand side. Now let's look at 2 cos 3x. For 2 cos 3x it's going to be a cos 3x plus b sin 3x, and for this sin 3x also it's going to be c sin 3x, e cos 3x. But again, since it's a cos 3x term with two constants, I would write it with a single constant to avoid unnecessary constants, because we have to focus on the nature of terms, not the actual terms which are getting individually. So just club them together to ease out calculations and minimize the undetermined coefficient. Similarly, b plus c times sine 3x can be simply written as a constant times sine 3x. So that's how you guess. So now let's look at some examples to understand the technique better. The simple ones, the non-simple ones will be done in the next video, and in the next video I'm going to discuss some miscellaneous problems, so that you can, looking at the question, you can decide whether it's a simple problem or a non-simple problem and accordingly guess your trial YP. Alright, so let's first look at this question which says there's a differential equation given to you and you have to use method of undetermined coefficients to find your solution. The solution, as we know, has got two parts, yc and yp, and for yc you will write your characteristic equation, which is r square minus r minus 6 in this case. Look at the nature of roots, they are real and distinct, so your answer looks like this. Now look at the right hand side. The right hand side is an exponential e to power 2x, so it's a straight away application of bullet number 1 of your table, e to power kx. For e to power kx, you just guess a e to power kx. Now since it's e to power 2x, your trial yp will be a e to power 2x. If that's your trial yp, look at the equation. The equation is y double dash minus y dash minus 6y. So y double dash minus y dash minus 6y equal to e to power 2x. This is the given differential equation. If this is your trial yp and you are claiming that this is a particular solution, it should satisfy. If it satisfies the derivative, the second order derivative, when you put it here, y double dash's value will be 4a e to power 2x, so you put it here, minus y dash is minus 2a e to power 2x, and then minus 6y. 6y is this, so it should satisfy the differential equation. I've just substituted your guess yp here in the given equation. If it is a solution, it should satisfy, and we have just substituted in the given differential equation. Now let's see, 4a e to power, all the terms are e to power 2x type terms, so let's club the constants together. 4a minus 2a minus 6a, that makes it minus 4a, right? It's going to be 2a minus 6a, that's minus 4a, and the right hand side is e to power 2x. Now these two expressions are exponential expressions. They can be equal only if the coefficients are the same. So that means minus 4a should be equal to 1. That means a should be minus 1 by 4. If a is minus 1 by 4, that means for your guess, the guess that you were making, the actual yp which works is going to be minus 1 by 4 e to power 2x. If you are not convinced, you can put it here to see that if you take y as minus 1 by 4 e to power 2x, this differential equation will be satisfied. You do not have to guess the trial yp here. You just have to put it in undetermined coefficients form, and the calculations will automatically land you into the correct choice of a. And the correct choice of a is minus 1 by 4 in this case. So your yp is obtained through the method of undetermined coefficients. The undetermined coefficient a takes the value minus 1 by 4, and the simple table is very much working here. So your solution looks like yc plus yp. This was your yc which you obtained in step number 1, looking at the roots of the characteristic equation, and your yp which you had guessed as a e to power 2x works for the choice a equal to minus 1 by 4. So this is your yp. So you are done. Now let's move on to the next problem. The next problem is y double dash plus y is x square by 2. Now again, we'll first find yc. Looking at the roots of the equation, you write your yc, and now look at the right hand side. The right hand side is x square into a constant. So whenever it's a power x to power m, according to the table, you have to take a linear combination of this and the reduced powers. So let's guess the function, since it's an x square type term on the right hand side. So we take x square and the reduced powers as our trial yp. The question is y double dash plus y equal to x square by 1000. That's the question. So if this is my guess, then it should satisfy the differential equation. I'm claiming that this, let us assume that this is one particular solution of this differential equation. If it is a solution, it should satisfy. If it satisfies, let's put the required derivatives yp dash, yp double dash are obtained, and you put it here. So what does it become? For yp double dash, it becomes 2a here plus the value of y, which is ax square plus bx plus c. That should satisfy the differential equation. That means this combination should be equal to x square by 1000. Again we apply the same logic here. There are two expressions which are equal, powers of x, a linear combination of powers of x which is equal only if and only if the coefficients of the like terms are equal. So let's see, this right hand side has only an x square term, and here the x square term is ax square, right? So that means a should be equal to 1 upon 1000. Now here there is an x term which is b, but there's no x term here, it's 0x, so that means b should be 0. And here the constant is 2a plus c, and here the constant is 0, so that means 2a plus c should be 0, b should be 0, a should be 1000 when we compare the coefficients of the like terms on both sides. This gives us the value of a and b, and of course c also using this equation. Once you know a, b, c, this was your trial yp, ax square plus bx plus c, you just put it here. That means your ax square plus bx plus c becomes, yp was ax square plus bx plus c. The value of a has turned out to be 1 upon 1000, so that's this. B has turned out to be 0, so I did not write it here, and c has turned out to be minus 1 by 500. So that means this is your final trial yp after obtaining the undetermined coefficients, and hence the final answer is yx equal to yc plus yp. So that is all about this video, friends. In the next video we are going to learn what non-simple cases are and how do we modify our trial yp in case it's a non-simple situation. Thank you so much for watching.